Let's look at question 39. Combination sum. Give array of distinct integer candidates and target integer. So give some candidates. This is integer array and a int target. All the number in this candidate is distinct. So find the list of all unique combination of these candidates where the sum of them is to the target. You can return in any order. The same number may be chosen from candidate an unlimited number of times. So from example 1, we say this 2 used 2 times. So for those type question, normally we will use exhaustive stage to calculate, and normally we can use the backtrack algorithm to do it. So backtrack algorithm, you can try some value, and normally we use recursive, call the recursive, and remove the value you used and go to the next possible value. So let us to write this backtrack function. So in the beginning we need some result. So if we find some result, we put this one into this list, and then we need this candidates, and then we need this new target, and every time we will try the value from these candidates, the position will be the start, and then we have the kernel information is this backtrack array. So every time we try this one, in that one we try one and remove. So we call values. So if the new target is 0, so every time we try some value, we need to reduce this target. If finally we find a new target is 0, it means we find it. So this one will result will add the new array list. The reason we create the new list because we cannot put this object into that one. We need to build the new list from its value. And else if new target is less than 0, because all the value is positive. So if you got the negative, you cannot go back. So in this one, we just return an else. So it means new target value still is positive. We can continue to reduce some value from the candidate. So we will try this one from our candidate. So start from start, and will less than the candidate line. So every time we will try the next value, and then we try it. So we get from candidates I1. Okay, and we add this one, and after try we need to remove it. Value size, we remove it, and then we try it. So we call the recursive function. So still the result and candidates and new target. In this new target, we try this one, so we minus this v and star from the I1. Because the reason is we can reuse some value, so we always try it first. So we still give the same star, and then is the values. So we finish this backtrack function, and then we will call it. So in the beginning, we create result, and then we create a list integer and values. We use this one to backtrack. And then we start to call the function, this recursive functions, first call. So the first call result is result candidates, and the next one is the target, and start from 0, and first give the empty values. So we use this one to try it. So first the empty one, and then we come to here, and we use the 2. Star is 0, so we use the 2, and they put 2 into this value array and try the next 2, and then when he try the third 2 is 6, and then they try the first 2. Okay, this is 8, so this is go to this one, it's not work. Then they try 3 2 with a 3, it doesn't work. With 6 doesn't work. With 7 doesn't work. Okay, so they give up. From here, we can do some operation optimize. So first we can sort this array. Okay, so we can do some optimize. So first we can do arrays sort candidates, and I think is A, B, return A minus B. Right? We sorted this one, and then we can give some signal. If that value is too big, so for that one, let me think, could we do it? Because after we try 3, it doesn't work. For this one, we give 0. This means work. For this one, we also give the 0. I don't know. We try. This one we give the one. So for that one, so if R is 0, it means we stop here. We find some value. Try this one. Because after we try 3, it's failed. We never need to try 6, 7. So we can save something. Okay, and run this one. Start lesson. It's candidate. We said the candidates. Okay. This is a properties, not the function. Here, I think it's this function. We need a return result. Okay, and let's submit it. Cool. So we are done. Thank you for watching the video.